Hello, everyone, and welcome to MATHurdays. My name is Teresa Wills. I'm an assistant professor at George Mason University in the Math Ed Leadership Office. I work with a lot of people who are math specialists or are in the program to become math specialists. I also work with a lot of pre-service teachers, and at least once a week I am in the classroom with actual kiddos in first through third grade. I started out as a secondary teacher, so I feel like I kind of got a large range of backgrounds and ways to support you in your online learning. Today we are going to work between two things: Collaborate, which is where you can hear me. You might be able to see the link I just sent, and Google Slides. Google Slides is what we will use primarily. It's a place where we can all edit together, and I hope that it's super useful for all of you. Alrighty, if you see on slide 1 at the very top, I have some pretty important buttons if you want to stay in contact with the most up-to-date things. I am putting YouTube videos out almost daily. You can follow me on Twitter. You can send me an email. If you like this PD and you want to try out some others, there's lots available in the PD registration. And I recently made a website, so links for that are right there. On slide 2, if you see a template in this class or any other class, you can access it at this link here. And if some of you are veterans of my classes, you're probably wondering, where did the gray slides go? At this point, everything has been uploaded to my website, so you can just click through there and find the things that you are looking for. And just as a heads up, this was also my email, but I am recording this session to be put publicly on YouTube, and it will be available a couple hours after the session's over. All right, come join me on slide 4. You are going to grab yourself a text box. It looks like this little box with a T in it. Put it somewhere on this screen and share with us, what are you celebrating right now? What successes have you done? And I'll ask a couple people to share out. Diana, tell us a little bit about finishing the semester.
Thank you. Sure. Well, as everybody, I guess we will have to move to the remote instruction. So yeah, it's been a lot of learning, a lot of extra work. We will have our next week. I'll have to hold a review session before our final exam. So I'm pretty excited. I'm happy I survived to all this transition, and I'm willing to learn more so I can go and teach my summer classes.
Well, we wish you the best of luck in your summer classes too and finishing up this semester. Ruth, what are you baking?
A lot of banana cakes and banana bread. I seem to have a lot of those left over. So that's been my main one. And then a cinnamon roll coffee cake.
Ooh, yummy. We also have a lot of very, very dark bananas. Let's see, lots of other things. Molly, where did you go for your walk? How long was your walk? Did you see any cool things out there?
Let's see, I went for about a 45-minute walk, and yeah, it was just nice to get out and get some fresh air and see the sunshine. So I'm feeling really good after that.
Awesome, exciting. Someone said they got parents involved. Let's hear a little bit about the parents being involved.
That was me. My name's Roisin, and I just keep emailing parents and letting them know when our online sessions are, when my extra help is, and they've been very appreciative of that.
Wonderful. Well, kudos to all of you who are here to do math on Saturdays. I pledge to you all to be patient and calm while learning the new technology. And I hope in turn you also promise to kind of enjoy the productive struggle that we're just here with other educators and just enjoy today. We're going to start off with a lovely routine that I really love called choral counting, and it's on slide 5. One of the authors of this fabulous book is with us here today, Elham Kazemi, and so hopefully I do this justice. And Elham, go ahead and give me feedback if there's anything else that I'm missing. But choral counting is a really great routine, and this is how you can do it online. I'm going to ask that all of you all, let's make sure microphones are off for now in case there's lag, but at home, if you would say these numbers out loud when they appear on your screen. So we are on slide 5, and here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Stop here and start to make some predictions. What numbers do you think will appear in the bottom boxes? Let's see if those predictions pan out. 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Pause for a minute. Think about what numbers will come next. 42, 44, 46, 48. And at this point, I might have students talk all the numbers out loud again. I might have them all turn on their microphones and say them all at the same time. You might want to test that out with lag with different computers, or maybe just have one person turn on their microphone for an entire row as we go along. But just saying the numbers is one thing. We really want to find some cool patterns in here. So join me on slide 7. I'm going to ask you if you see an awesome pattern that should be recognized, if you would go ahead and raise your hand, turn on your microphone, and tell us what is the neat pattern that you are seeing. Go ahead, Lynn.
I noticed that each column is increasing by 10. So if you look at the last column, that has the word 10, and then the bottom column has 60. So each one, as they were going down, increased by 10.
Neat. So we saw increased by 10. And I really like how you use that term column. And I'm going to use this little green arrow just to show that increased by 10. Who else sees a neat pattern? What other patterns are there? Beatrice?
And then take your mic off.
Yes, going across the top column, it's increasing by 2.
Ah, so am I pointing to the right place from here to here?
Yes.
Okay. Very neat. So we are seeing an increase of 2 going in this direction. And I see another hand up, but let me record Beatrice's thinking. Rosen, go ahead. Michelle?
So going from 2 to 14 to 26 to 38 diagonal, you're increasing that one by 12.
Oh, can you tell us a little bit more? How did your brain think of 12?
Well, at first I was doing 2 times 7, which got me to 14. But then when I tried to do times 7 again, it didn't work. So I said, well, maybe it's adding instead of multiplying, because going across you're multiplying by 2, but you're also adding by 2. So I was just looking for the pattern, if it was multiplying or adding. And that was my thinking. And then I saw like all the diagonals are kind of doing something different, it seems. Or maybe not.
Interesting.
2, 24, no, maybe not.
Very cool. All right, let's hear Tamika, what do you see?
Thank you. I see the exact same thing, but the opposite directions. So it's decreasing by 12.
Do you think you could grab that little pointer finger and show us the numbers that are decreasing by 12?
So starting with 60, going back the opposite way, well, going that way.
Okay, so
60 to
60 to
48,
48.
36.
Okay. Rachel, what do you notice?
I was just going to add on to what the previous two women had said, either adding or decreasing by 12. I noticed that we add 1 to the tens place and 2 to the ones place.
Tell me more about adding 1 to the tens place.
If you look, like when we start at 14 and then we add 1 to the tens place, so now it's, instead of 1, it's 2. And then the 4 in the ones place, we add 2 to that and it becomes 6. And from 26 to 38, we add 1 more in the tens place, so 1 more 10 would make it 30, and then 2 more 1s would make it 8.
So I heard 2 things here that are really interesting to me. And the first one was how you focus on the tens place. So I'm going to record that over here. And then you also said something about 2s. Can you rephrase that again? Say that again for me.
Sure. I would notice that as we increase either going diagonally and going horizontally, we're adding 2 to the ones place.
Okay, let me try and get your exact words. We are adding 2 to the ones place horizontal. All right, so this is going to be an interesting one to show here. So we're adding 2 to the ones place. I might even kind of circle these little ones places to make it really obvious what we're talking about. Am I highlighting it the way that you're describing it?
Yes.
Awesome. All right, folks. Well, this is, I really worked hard on the notation of choral counting. I definitely have some more work to do in my pedagogy and asking you all questions about it and displaying it here. But what I would love from anyone else who uses choral counting regularly, if you have feedback on this template, things that looked easy about it, things that looked complicated about it, or just anything else that is missing on it, I'd love to get some feedback because I'm a believer that online learning can be just as good as face-to-face. We just need to figure out how to trick the technology into doing that. So we've got an example of choral counting here with even numbers. And on slide 8 and 9, thanks to Molly, who is here with us today, we have some for those who teach in some other grade levels where you might want to use things like fractions. Or on slide 9, I know students frequently get into sequences and series in the secondary. I have one of my favorite series here, and I hope that you see ways of using this routine in your class. So let's dive right into our rich task. Why most of us are here today is to get a routine and a task. On slide 10, I have the rationale for why we do rich tasks, and I am certain that you will see every single one of these math teaching practices from NCTM in today's task. I ask you to look at this list and think to yourself, what's one area that I want to improve on as an educator? Maybe jot that down somewhere, but really be on the lookout for that today. On slide 11 is just a reminder that in the classroom, I would usually ask students to use concrete, pictorial, and abstract. I'm going to ask you all also to use technology. And if you join me on slide 12, this is the problem-solving oath that I always ask all my students to do. I'm going to ask you to read that to yourself. If you agree to do everything on this oath, please type your name in the chat box. Wonderful. I'm glad to see there's so many mathematicians out there. If you join me on slide 14, this is our rich task for today. It's Goldilocks and the Three Bears with a cookie remix. So on slide 14, we have our task. Goldilocks visited the Three Bears' house and noticed 3 plates of cookies. Each plate had a different amount of cookies. Baby Bear had the least, Papa Bear had the most, and Mama Bear had an amount in between. But no plates had equal amounts, and no plates are empty. There were a dozen cookies total. How many cookies could be on each plate? That's your problem to solve in groups. Slide 15 has some nice clip art you might choose to use to copy and paste when solving this. It also has great manipulatives for elementary and secondary folks. And today you are going to be grouped in grade levels that you teach. So hopefully you can kind of talk about how your grade level might solve this problem. The way I'm doing that is in the breakout rooms. I'm going to create a bunch of breakout rooms. And once a room has at least 5 in it, we're going to start up a new room. If you are a K2 teacher, I'm going to have you go to group 1. A 3-5 teacher is group 2. A 6-8 teacher is group 3, and high school teachers are group 4. You're going to move yourself. The way that you'll do that is in Collaborate. You will click on the attendees screen where you see everybody's name, and then click the little green arrow to go into that group. Again, you'll start in Collaborate. You'll look at the Attendees tab, scroll way down, and click the green arrow to go into that group. Again, you'll go into Collaborate. You'll move to the Attendees tab at the very bottom next to the chat box. You'll scroll way down and enter that group. And don't worry, I will be patient and support you through this. If you're still in the main room and you need a new group, let me know what grade you're in and I can help you to get there. Mary?
I'm in 5th grade. I forgot what group you said.
No worries. That is group number 2. And you know what? I'm actually going to kind of split that group up. They're really large right now. So if you would like to head down to group 5, that's where I'm going to put some of them. And I'll put you there too. Joy, Beatrice, and Laura, can I help you to go to a certain grade level?
Oh, sorry, this is Joy. I'm in sixth grade. I was
Sixth
doing
grade.
something.
No problem. Joy, I'm going to put you in a new room with other 6 through 8 teachers.
Okay. What group would that be?
Group 6.
Okay, thank you.
Yep. Joy and Laura, if you are here and you want support moving into a group, just let me know. Hi, Beatrice. I can hear you.
Hi, am I in group 3?
What grade level do you teach?
Am I in group 3?
It depends. What grade do you teach?
What grade is group 3?
Group 6 now. You took too long. You got to scroll down to group 6.
I would pick in high school, maybe they would like formulate some type of proportion or something like that. I don't know.
My kids probably would just start grabbing and see what they can do.
Hi there,
Not sure.
secondary folks.
Hi.
I am secondary at heart, but I also try and get problems that work with elementary school kids as well. How do you, in your subject area, use things like tables and graphs to see all possible permutations or combinations? And how might a high school student maybe use some of that knowledge to solve this?
My kids would probably just mess around with it at first, just to move cookies around. But I'm hoping that it leads to them making some type of table.
Yeah, so if you guys could work on like how might you want, like in a perfect world, what would you want your students to be able to do with this problem? And that will really help our elementary students to see ways that what they're teaching them is important for where they're going, and hopefully make a problem that you all can use in your classroom.
Oh, let's see.
I'm not exactly sure. How to
Oh, one.
Hi there, Group 6. I'm just checking in. Does anyone need anything or just some time to think?
Time to think. We're trying to grab the cookies.
Oh, great.
Yeah, we had 2 slides, I think, 21 and 22. So we were at first on both of them.
Nice. I'm going to do you guys a little favor here so you can see your slides. A little trick. I just changed the background color to green, so sometimes that helps people keep track of which slides are their groups.
Oh, sounds good. Thank you. Okay, reading the problem again, it said that Baby Bear had the least, Papa Bear had the most, and Mama Bear had an amount that was in between, but no plate had equal amounts and no plate was empty. And there's a dozen of cookies. So what do we think?
That's what I was trying to do here with this chart, but it's not, the table doesn't, it's not cooperating with me. There we go.
Oh, you put, okay. Bear has 5 and Mama Bear has 4 and Baby Bear has 3.
Any other strategy or?
Hi, group 2. I love the way that you explained your steps for splitting apart these cookies. What a great thing to have on your slide.
Thank you.
Thanks.
So it makes me wonder, is this definitely what Goldilocks sees? Is there any possibility of her seeing something different?
Also have a second strategy over to the right. Someone suggested having 1 cookie on the baby's plate, 2 on the mom's, and 3 on the dad's, and then continuing to add 1 until they're all gone, which would give us 3, 4, and 5.
Oh, neat. So we have a 3 for baby, 4 for mama, 5 for papa.
Yes.
So there's 2 ways that you all found that these plates could be arranged. Are there any other ways?
Well, another way we could do it is that baby has 1, the mom has 2, and the rest goes to dad as long as they're not equal.
Oh, it sounds like you have more ideas. How are you going to keep record of all those ideas?
Could we keep typing our explanation?
Sure, absolutely. That is a fabulous way of doing it.
Thanks.
Okay, I'm there.
Hi there, group 3. What are you all thinking about?
They want to go fractions on us.
Oh, way to go. All right. I totally didn't think of fractions here. That's such a great extension.
We wrote some questions in the note section, like how can we adapt it, starting easy and then getting more difficult. And then I forgot the lady who said forcing the fraction where we only have 5 cookies, then they would have to make fractions or I don't know. Maybe 2 cookies.
We just went back to, right, but we all agreed that you need to start like with whole numbers and then build to the fractions.
Yes.
So cool. All right, I'm going to ask you guys a very special favor. Since you have a couple different ways of doing this, would you find a way to keep a record of what you could do for baby, mama, and papa bear with these fractional amounts?
Okay.
Very cool.
So, okay.
We could put a little, like, tape.
Yeah, I think there are all the combinations.
Yeah.
Hey there, team.
Yes.
I just heard an amazing thing from you all that those are all the combinations. So how do you know?
If we put different numbers in, it wouldn't meet the criteria that was in the original problem, that nobody has the same amount on their plate, and that Papa Bear had the most.
And if we started thinking on an algebraic level, how might these numbers look in a graph? Would students ever graph these? Would we expect a certain shape to appear in the graph? How might this transfer to some algebra?
Well, you have three variables, so you'd have to determine the relationship between each. So like if you called baby bear X, you would have to determine if mama bear is X plus 1, X plus 2.
Let's just give some space to.
Yeah, and so frequently we use only two variables, like an x and a y, and occasionally we have things like a y1 and a y2, but like that's kind of in one chapter, a little isolated. Group 4, feel free, here I'll make you a duplicate slide. It looks like you're just trying to get some extra room. So you have 2 slides to work on now. You can delete some of that extra junk, the plates out of the way. But what would your dependent variable be for this? And which one, like what's independent and how might that work for algebra kids?
So it can maybe even put like some restrictions, like formulated, like, I don't know, like baby has to be less than M less than P, like some restrictions like that initially. And then P plus M plus P equal 12. P, okay, so this is our second slide, so we can see this, right?
And then what grade level or what content area in math do you all teach?
Oh, I'm actually teaching programming. So.
Oh, wow.
And
Could you imagine this one as a program? This would be phenomenal, right?
Yeah.
I teach algebra 2.
Okay, very cool. So in Algebra 2, in your state, do you guys do permutations and combinations at all?
Not really. It's an algebra 1 topic.
Gotcha. Okay. Yeah, this one is slightly annoying to the rule of typical permutations combinations, which would also work in programming here. But it's annoying in that it doesn't allow for zero and it doesn't allow for matches. So there's these like restriction rules. And I encourage you all to kind of investigate those restrictions some more. And you know, if students were to come up with all these responses in a calculator, how might they sift through it to get out those restrictions?
So obviously each of them would have to be greater than 0. So that's a restriction. And then
I can't find the half symbol. Oh, someone's trying to get it in special characters. Does anyone see the half? Oh, there you go. Thank you.
Mhm. Does anyone want to try and draw it, or we could even sketch it like in front of you, and then we could add a picture? Or if someone's good at the Google tools of drawing, that's certainly something I'm working on still. I will copy this. So we've got one more if we want to do it on slide 19. I don't know if anyone wants to try and draw them there.
Draw the cookies?
Yeah. Maybe a different solution, like, oh, let's see what else. Because we have one where they're all pretty close, that the one with the 3, 4, 5. The first one, another sequence of 2, 4, 6. Could we do one where like Papa has 6, Mama has 5 2/3, and baby gets a third or something like that?
Yeah.
Let's see. How do you want to represent that? I don't know. That's a good question. It's especially hard with drawing it, because especially the thirds. Let's see.
Well, we could go grab, I always use the Math Learning Center apps for drawing out fractions. I could probably go, if we have time, go grab one of their circle, and I'll just break it into thirds and then bring it back in.
Yeah, that sounds great.
Let me see if I have time to do it before she pulls us back.
Mm-hmm.
I just copied the half a cookie that the other team did. I don't know how they did that half cookie. I'm curious.
Awesome, thank you.
Okay, so you said Mama's getting 2/3?
Yep.
Okay. And baby's getting 1/3?
Mm-hmm.
Okay. All right, let me go grab this.
Welcome back, everyone, to the main room. Hello, hello, and welcome back. We are all back together in the main room, and I have muted your microphones, which means you'll need to unmute them when you come back. Alrighty, so I'm so glad you guys had some chance to interact with this problem with folks who teach a similar grade level as you. And I'd like us to take just a few minutes and talk about this problem in a math talk. So what I've done is I have so many Post-it notes down in front of me. I followed these steps on slide 29. So this comes out of the 5 practices for orchestrating productive math discussions from Peg Smith and Mary Kay Stein. And this is kind of my toolbox for pretty much all math that I do. I come up with a rich task that has lots of ways of solving it. I've anticipated about 22 ways that I was expecting this problem to be solved. I monitored, you probably saw me going into your different different sections, and I have Post-it notes all in front of me where I am selecting these different tasks to go over. I don't always pick every group. As a matter of fact, often I don't pick every group. I am simply picking the ones that are going to lead to a great math discussion. I put them in a certain order, and I even add questions on my slide to help you connect the different ones. We're going to start out on slide 30. If you wouldn't mind coming on down to slide 30. And if this group can explain to us, why did you start out with 3, 4, and 5? What was your thought process here? Someone from group 6. Why did you guys start with 3, 4, and 5?
I'm part of group 6, and we just, I think we're thinking initially whole numbers and knowing that Baby Bear had to have the least amount. So just kind of almost like a guess and check. If we did 3, one more than that would be 4 for Mama Bear. So now that's 7, and then 5 left over for Papa Bear. So he has the most.
So those numbers just kind of worked out nicely for you. Group number 5 on slide 31, they started out differently. They started out with 1, 2, and more. Can group 5 tell us, why did you go this way?
I can talk about it. We were thinking about, we started realizing you could be systematic about it, and you could think about what are all the possible combinations if Baby Bear only had 1 cookie. And then we went to 2 cookies and then 3 cookies for Baby Bear, and then looking at just what Mama and Papa might have. But just looking at group 6's slides from before, I realized we didn't even consider going into the fractions. We just thought of all whole number combinations.
Yeah, so let's kind of talk for a minute. Why might starting with 1, they use that word systematic, why might that be a useful strategy in solving this problem? Anyone? Laura?
Yeah, so we were trying to think like 3rd, 4th, and 5th graders would want to keep some things constant. Otherwise, they might get overwhelmed and they might get, kind of lost in the different combinations. So encouraging our 3rd, 4th, and 5th graders to keep one thing constant. So starting with Baby Bear having 1 cookie would kind of help them systematically go through the different possibilities.
Yes, absolutely. And that helped me too. Did anyone else feel like that helped them? Feel free to write comments in the chat box too while we're doing these. And we saw some different representations there with them literally putting the cookies on the plate. But on slide 32, they didn't put any cookies there. Group 1, tell us what you were thinking on slide 32.
we went to use the Unifix cubes, and so we just kind of divided them kind of evenly-ish. So it was the 3, 4, 5. So we used the Unifix cubes to show those as the cookies.
And why might Unifix cubes be really useful for kindergartner through second graders in solving this problem? Why might teachers want to use that and students want to grab for those? Lynn?
It's a very concrete and tangible way, and kinesthetically as well, for children to make the connection between the cube and the cookie. And then they can physically move the blocks around to make the various combinations of 12. They may not be able to do it abstractly in their head just yet.
Nice. Absolutely. Malia?
I also like this model when you're comparing amounts, because it's easy for them to see how much more and how much less you might have in different groups.
Absolutely. And I know some groups were talking about you can't have duplicates or the same size. And for a younger student who's using Unifix cubes, they might see the same size because they're the same size tower. They're not taller or shorter. Let's head down to slide, I'm going to reorder these real quick, slide 33. And this time, thank you, Group 5, for being patient before when you were pasting it. I was the one deleting it because I'm sequencing these. On slide 33, they have this really cool looking model up by the arrow. Group 5, can you tell us a little bit about this model, what it means, and how it helped you?
So we did the clip arts of the cookies first because we figured a lot of our third, fourth, and fifth graders would be wanting to think literally first. But then we started to play around with the virtual manipulatives, and these are the Cuisinart rods. And so we wanted to show what was happening in the table, but visually. So this is using the Cuisinart rods to show that 1 is constant for Baby Bear, and the total always has to be 12. So Mama and Papa are essentially combinations that make 11, and Baby Bear is the constant that never changes. So we just thought kids might be able to see that visually what is happening in the table.
I really, on a personal level, love that you use the Cuisinart rods, because for me, when I was a math coach, I would always find access to those because people weren't really sure how to use them. So they would always be collecting dust, and I could grab them whenever I needed. But yeah, here we've got that kind of constant of Baby Bear, and you're just changing 2 variables. On slide 34, they use Cuisinart rods differently. Group 1, where were your thinking going here?
This is Karen. We were just trying to think of ways that we could show it in fractions. And so we decided the Cuisinart rod was a great way because it is equal shares, and you could see it on the grid paper that it was precise. And then we ended up going on our slide after this, actually going into the Math Learning Center and grabbing a fraction circle and filling it in, and then showing fractions in a different way.
Neat.
After this.
So we've got the Cuisinart rods in a little bit of a different form here for fractions. I invite you all to just take a moment from what you've learned in the previous slides and play around with slide 35 and 36. And as you're playing around with these 2 slides, you can just take a row, turn on your mic when you have an aha moment and share with us what connection are you making to another slide. I see on slide 36 someone's changing the color. What's your thought process here?
I started with keeping that one constant, which one group had talked about. The baby bear just gets that one orange cookie. And then I was trying to make it kind of fair-ish between Mama Bear and Papa Bear. So I've got 5 for Mama Bear and 6 for Papa Bear.
Very cool. Someone said that this connects to the Cuisinart rods. Can you be a little more specific? Turn on your mic and tell us, how do they connect?
So looking at slide 36, definitely I had a connection to the Cuisinart rods, because the idea of the Cuisinart rods is that the total is constant, that you're seeing the group of cookies as a whole, and then you're subdividing Mama, Papa Bear, and Baby Bear within that whole. So here on slide 36, like the set is not changing unless a kid like takes away one of those circles. So it's that same connection and that constant with Baby Bear having one cookie.
Very, very well stated there. Raha, go ahead.
You know, as Lara was talking about set and the Cuisinart rods, it made me think about it's a great way to connect area model to set model and fractions, because that's something that fourth graders are getting used to and how they're the same, but they're a little different. So this would be a great way to show that connection.
Raha, I love that you mentioned that, because sometimes when students get this problem, there are always a couple of kiddos who think of a dozen as being one. So they've renamed their whole to one. And when they talk about how many are on each plate, you know, they might say that there's one cookie, 2 cookies, 9 cookies. But you'll sometimes get those folks that are like, oh, well, there's 3/12 on this plate, there's 4/12 on that plate, and 5/12 on the other plate. And usually that happens when you give this task right after the fraction unit, because that's what's in their head. That's what is there. But absolutely. Let's see, on slide number 39, let's head down to slide 39. And how were you all thinking of these little cookies? What's going on here?
So this is Tamika. I think this was our group. We were basically like middle school, 6th through 8th grade, and we were trying to make it a little bit more rigorous to include fractional parts, so that students could use what they know about fractions to solve this problem. So we were thinking halves, and then we were like, well, what about thirds? So we were kind of toying with the whole idea.
And then we also came up with some questions like, once they set it, we could then do an extension. What if daddy wants 3 times more than the other 2? Or what if mom wants half of what is already on her plate? So we were just trying to figure out how to adapt it to variables and fractions, and do we provide the cookies for them, or do we let them crop like we did?
The other thing you could do is you can actually give the same problem, but break your students up into groups, like keep all the low kids together and they just have to do a whole number, and your higher ones can do what we talked about. You kind of change it. Papa has to have twice as many as baby, and so forth.
Right.
Neat. So you guys have altered the rigor of this without really changing the problem. And one thing that's amazing about that is when we talk about access for students, everyone in your class can participate in the whole group discussion afterwards, whether they used whole numbers, fractional numbers, or had some other way of looking at this problem that we can really respect and highlight all these different ways of solving it. On slide 40, we had some of our secondary teachers here, and one in particular talking about computer programming in this problem. So would you tell us a little bit more about what your students do in programming and how you might use this?
Sure. So, well, the first thing we did here was a table, right, with the variables. And also we were planting some restrictions for those variables, right? For programming in particular, this will be useful to, for example, using loops, right? So we can see the variable b going from 1 to 3, the variable m to 2 to 4, and p from 9 to 5, and then these will be useful for teaching those type of nested loops in programming.
Wonderful. Thank you, Diana, for sharing. So those of you who did this problem actually comes up with less of the storybook characters, but it comes up in high school Algebra 1 or in a prob stats course for permutations and combinations. You might have heard of the locker combination, where you figure out how many ways, how many possible combinations there are on a lock. Except this one is rather annoying. It doesn't allow for repeats. It doesn't allow for 0 cookies, and it's annoying like that, which makes it fun to work with. All right, folks, we are going to sum up because our time is up. I hope I did this a little bit of justice with the whole group conversation here. My main questions were on slide 41. I wanted you to focus on creating an organized record, whether it was through tree diagrams, tables, or graphs. How do you know for sure that you accounted for all possibilities? That question is going to bring your rigor up really high. Some groups created this new notation with parentheses and commas. And I would also ask students, what generalizations did you make about repeats? And how did you account for that? I would ask, before you head out, if you can just find a spot on slide 42 or 43 and tell us what grade level could solve this problem. And you might put in third because, and then blank. Like, tell us what the topic is you do at that grade so we could see how far this problem stretches. I'm seeing first, second, fifth, sixth, seventh. And indeed, I am hoping that you find a way to adapt this for your students so you have a lesson for next week. Awesome. I'm going to head down to the virtual parking lot. It is the very last slide, and I'm going to take any questions. I encourage you all to please try this out with your students. Assume they can do more than you think they can, and give them the open space and the just creativity to allow themselves to play around with the mathematics. This has been a pleasure. I look forward to Saturdays. This is the most fun day of the week because I get to be with all of you. And at this point, I will take any questions. Y'all are welcome to stay for those. But if not, I know you all have wonderful things you're going to do on this Saturday. Join me next week for another new task and new discussion. How did you animate slide 5 with Coral Count without being in present mode? I would love to show this, and I'm going to share my screen for it. Alrighty, I am up at the top. I made an extra one just for representing this. I'm on slide 5. And what I do a few minutes before we start, this is a little bit of a hack. I mean, it's not what Google Slides were meant to do, but I found a way of using what they got and making it work for me. Slide 5 is complete, but I want it to show 2, 4, 6, 8, and so on. So the trick I did was I just went back and I started deleting these boxes in the order that I pasted them there. So this does take a couple of seconds to do. You want to do it right beforehand because Google does, like if you restore your pages or you close this down and reopen it, it won't do it. But then all I have to do is really easy. I hold Control down and I do Control Z, pop, Control Z, pop, Control Z, and they just pop right up. So again, it's a little clunky, but it does what I would have done in a face-to-face classroom, which is I wouldn't have the numbers up there already. I want students to have that moment of anticipation, the excitement when they're right with the next number. Do you let students make their own groups? It depends on the task. So in that case today, you all made groups with similar grade levels, and I really wanted to respect the important mathematics that kids do at each grade level without, doing too high of a vertical articulation. Sometimes I'll just put on slides, here's your groups. Group 1 is Teresa and Molly. Group 2, and I'll just type them in where students don't get a choice, but they're doing the work of moving so that there's less on my end. How did one group split the cookie? One thing you can do is take the clip art image, go to the crop feature. If you don't know about the crop feature, this is going to be your new favorite thing. We've got the crop feature, and you just slide it over, and wait, that just resized it. I didn't click it. Get these little black lines, scoot it over. Now you got a half a cookie. Let's see.
Can I ask you a question about the moderator? Like, I can just let my students pick their own groups, right? They can just join?
Yeah.
Okay. Thank you.
Yeah,
Thank you.
absolutely. When do you use locked slides versus unlocked slides? You see this virtual parking lot? If I try and move the background, those cars aren't going anywhere because I really don't want them to go anywhere. So this is a locked slide, which basically means I went to the background and I just picked an image. Once I'm in here, I pick the image of the virtual parking lot. I have a whole bunch of images, but I could just change it, and then it's just a background, but it allows it so that students don't move it around. I'm going to undo that though. Do you usually advise students a split screen to see the chat and the slides? I encourage you to check out the video on how I do split screens. There's a nice rationale for it. Let's see, I'll put it in here because I just took a picture of it. On my website, there's tips and PD videos. And the split screen, is it this one? I think it might be. Yes. I'm showing two screens right now, so pardon that. But on slide 48, you can see that I have Collaborate stuck in the background so that I can see the chat box and my microphone, and I keep my Google Slides on top, and I just have them staggered. Let me get you that link for the video. Yeah, I do have a video for it, and I try to explain the rationale for why you might keep it like that. Let me get you the video. Here it is. I'll put it right next to. There you go. That's the video. It'll tell you all about staggering windows. It's less than a minute long, so hopefully it gets to the point pretty quickly. Somebody asked a question about, do I send you links and so on for Blackboard? I send you all a public link, and I do realize that I'm taking a risk in sending a public link, and that could get in a hairy situation pretty quickly. Usually if you're in a school that has Collaborate, you can ask students, you can send them a button within Blackboard and they would log in and go that way. Their real identity is there. and there are some ways to have extra accountability. And so if you are interested in learning more about that, I hold an accountability and classroom management session. I'm happy to answer those questions now, but I do a whole session on that also if you're interested in signing up. And I talk about some of the things where accountability really matters and ways to make your classes run smoothly. I think I've gotten to all the questions. If I didn't or I didn't answer it well enough, go ahead and take over the mic and let me know. Sure thing, everyone. Well, have a wonderful Saturday. I'm so happy to have spent it with you, and go out and be awesome. Good luck with your online learning.